Okay, so in lesson 4, the area of polygons through composition and decomposition, we're going to be looking at some irregular figures. Irregular figures are figures that don't have an actual name for the shape that they are. It's usually a combination of multiple shapes or can be broken down. So if we look at the first piece here, it's giving us an aerial view of a woodlot that would be shaped like that. Again, we don't have a name for this shape. So if you look, what it's doing is it's giving you the side lengths of some of the sides, and it's asking you to use those sides to figure out the lengths of the other sides. So if we read here, it says length of AB is 10 units. So from here at A to here at B, it would be 10. FE is 8 units, so from here to here, that's 8. AF, this side right here, is 6. And DE, right here, is 7. They want us to find DC and then BC. So if we look, DC is a small little section right here to here. It would also be the same as here to here, just if we were to kind of make this into a rectangle with an invisible line, the opposite sides would be equal. Now, if you can see, A to B, the whole thing is 10, and the difference between this whole side and this little piece has to do with side FE. If I take 10, or AB's length, and subtract 8, or FE's length, the leftover will give me DC, because this from here to here, plus this small little piece here, which is this to this, or this to this, would give me that small length. So I'm taking AB, subtracting FE, and that will give me DC. So AB is 10 minus FE, which is 8, tells me that DC is 2. Looking at BC, this is a longer side here. And if I think about cutting it this way, I can see this rectangle has the opposite side from this, which means this space here is also 6. And then that also cuts it into this little rectangle, which shows me that ED is 7, so that means from that space down over here is also 7. So the length of BC would be the length of AF's opposite plus the length of ED's opposite. So I'm doing AF plus DE, or 6 plus 7 and getting 13. Okay, so it's just using other sides of a shape to figure out missing sides. The next one is a similar example. This time it's telling us different numbers for different side lengths, so be careful. DC here is 10. FE is 30. AF is 28. And BC is 54. Now they want us to find AB and DE. So it's kind of the opposite of what we just did before. So again, we can kind of split our rectangles. This is 10, so that means from here to here would be 10. This from here to here is 30, so that means this from here to here would be 30. So to find the length of AB, I would be adding FE plus DC, or 30 plus 10 to get 40. For DE, to figure out that length, I have 54 here, but if I were to cut this top rectangle made up here, this would be 28 between here. So if I take the full length of BC and subtract out the 28, that will give me what's left here, which would also be the same for DE. So I'm taking BC, subtracting AF. So BC is 54 minus AF, which is 28, and getting 26. So again, using what we know about rectangles and opposite side lengths to determine missing sides. So knowing that information, we're going to look at breaking down some irregular figures to find their area. So this says the intermediate school is producing a play that needs a special stage built. Diagram is shown below, not to scale. On the first diagram, divide the stage into 3 rectangles using 2 horizontal lines. Now remember, horizontal would be like this. So find the dimensions of these rectangles and then calculate the area of each, then find the total area of the stage. So 2 horizontal lines would mean I would have to put my lines here and here to create 1, 2, 3 rectangles. From this, I can see that this rectangle's area would be easy to find. So let's call that rectangle 2. So we have rectangle 1, rectangle 2, and rectangle 3. Again, it doesn't really matter which one's which, it's just the way I numbered them. Rectangle 2, again, for a rectangle, it's length times width. It's clear to see the sides are already here, so this is 4, this is 2. So 4 times 2 is 8. So this has an area of 8. Now, looking at this, we can see from here to here and here to here are the same side length, so this would also be 4, meaning that rectangle 1 is the same size. So it's a 4 by 2 rectangle, meaning it has an area of 8. The last one is a little bit trickier. We know one of the dimensions is 7. However, we don't know this dimension, this shorter one, because the 9 is talking about this entire side length. However, since we know this is 4, that means we know this is 4 as well. So if the whole thing is 9, but this piece of it is 4, to find the length of this side, we would do 9 minus 4 and get 5. So the area of rectangle 3 can be found by multiplying 7 times 5, which is 35. To find the total area of the stage then, I would take 35 and add it to 8 and 8, which gives me 51 square meters. Okay, let's look at the next one. You're going to notice the next one looks very similar. It's the same exact picture. This time, though, it says, on the second diagram, divide the stage into 3 rectangles using 2 vertical lines. Remember, vertical splits a V directly in half, so those are up and down lines. Find the dimensions, calculate the area, and then find the total area of the stage. So to do this, I would be drawing my lines right here to make my 3 rectangles. We'll just do 1, 2, 3 here. So we've got rectangle 1, rectangle 2, and rectangle 3. Rectangle 1, the dimensions are already there for us. This side length is 2, this side length is 9. So to find the area of that rectangle, length times width, again, 9 times 2, which is 18. Same thing goes actually for rectangle 3. If this side is 9, that means this side is also 9. And again, the shorter side is 2, so we have, rectangle 3, the same size rectangle, 9 times 2, or 18. Now, for rectangle 2, it's a little different. We know that this full side is 7, so I'm just going to move that down here. This piece from here to here is 2, because across from that is also 2. And the same goes over here. Across from here is 2, so this piece here is 2. Now, to get to the 7, so far we have 2 plus 2, or 4. So I would do 7 minus 4 to see that that missing piece in the middle would be 3. We also have to find the length of this side in this rectangle. We can use what we know about the other sides to help us out here. So we know that this full length here is 9. And as we saw from before, this to this was 4, which means this to this is also 4. And 9 minus 4, or the piece that we're looking for here, is 9 minus 4, or 5. Okay, so that one's a little bit tricky. We can kind of look at it, I guess, better on this side. This full length is 9, and then to find this piece missing here, it's the 9 minus 4, or 5. So here for this one, we do 5 times 3, which is 15. We want to add them all together, and if we did it correct, we should get the same exact area that we did in the first one, which we do. Okay, one more. So for this one, again, it's the same stage. This time the directions want us to divide the stage into 3 rectangles using one horizontal line and one vertical line. Find the dimensions of these rectangles and calculate the area of each, then find the total area. So now where you put these lines is, you can kind of do it interchangeably. I maybe would put my horizontal here and my vertical here, just because I have the dimensions of those rectangles if I do it that way. Here the 4 is already there and the 2 is already there, and on this rectangle the 2 is already there and the 9 is already there. So if I call these 1 and 2, rectangle 1 is a 9 by 2, or 18 units, square units I should say. And rectangle 2 is a 4 by 2, or 8. Now I just need to figure out the dimensions of the other rectangle, or rectangle 3 I'll call it. Remember that this is a full 7. We know this is 2 from here to here. So 7 minus 2 would give us 5, and I'm just going to cross that out, for this piece right here. Over here, we know this full length is 9. So from here to here is 4. So this piece right here would be 9 minus 4, or 5. So rectangle 3 would be a 5 by 5 rectangle, or 25. So now if we add all of these up, I get my 51 square meters that way. So again, you have to really look at what's already there, break it up into different figures. This shows us that we can break it down into different ways, whether we're using horizontal lines, vertical lines, or a combination thereof. Okay, let's look at another one. This next one, we've kind of already talked about parallelograms. This one, if we show it as a rectangle instead, so what I'm going to do is I'm going to draw a line here, and if you look, you have a rectangle formed from this. Something else to notice is you have 2 triangles on the end here. One is just used to find the height of your parallelogram, but notice it's the same exact size as this other piece that sticks out. So if I find the area of this rectangle here, it's actually going to be the same exact area as the parallelogram, because this outside piece here doesn't really count, but it's the same size as this, so it would. So we know when finding the area of a parallelogram that we're going to do base times height. So we would be doing 6 times 4 here to get 24 square meters. The next one is a trapezoid. Now, one way that you can find the area of a trapezoid is by breaking it down into 2 triangles by splitting it diagonally. So if I were to take my pen and draw a line from here, here across to here, I've made 2 triangles. This triangle right here and this triangle right here. Now, triangle ABC, which I'm going to call triangle 1, and triangle ADC, which I'll call triangle 2, have the same height. This height talks about the height of this triangle, because it's coming out of here at a right angle, and this is our base. And then I've also got this triangle having that same height, because here's our base and this is the height coming out of it at the right angle. So what I'm going to do is find the area of each triangle. So triangle 1, area equals base times height divided by 2. Our base is 8, our height is 5. So 8 times 5 is 40. Divide that by 2 and get 20. For triangle 2, my base is 4 and my height is 5. So again, using my formula, base times height divided by 2. 4 times 5 divided by 2, or 20 divided by 2, which is 10. For the entire trapezoid, I would add the two triangles together. 20 plus 10 is 30 square meters. For the last example, we have a kite. In this kite, you'll notice it's already been split for us into 4 triangles. Triangle 1, triangle 2, triangle 3, triangle 4. Now it's made into 4 right triangles, so we should be able to do this fairly easily. So triangle 1, area equals base times height divided by 2. Here we have a side of 3 and a side of 4. That's where the right angle is meeting them, so that's our base and our height. So 3 times 4 divided by 2 is 12 divided by 2, or 6. For triangle 2, our right angle is here, so we have a base of 3 and a height of 9, or the opposite. So we get 3 times 9 divided by 2. Okay, so we would do 27 divided by 2. Which is 13.5. Now, if we look ahead, triangle 3 is the same size as triangle 1. It's got a base and a height of 3 and 4. So that means I would need 2 of these. So this is also triangle 3. And then triangle 4 is the same size as triangle 2, a base of 3, a height of 9. So when I go to add these all together, I want to make sure that I do 2 6s and 2 13.5s. Now when I line these up, I'm going to line them up like this. And I'm going to put point zeros for the 6s. And I get 39. And it's square meters. Okay, so today we've just kind of seen how you can break down the inside of figures to find the area of them. Go ahead and start your play posit. Make sure that you are following all of the directions and breaking down the shapes the best you can.